Okay, so basically with this one, it's as long as you have the correct picture, then most people usually do pretty well with it. I think it's coming up with the correct picture that's the hardest part. So let me see if I can help you with that. So basically, we're just going to start by, let's just kind of read through here. Okay, from her elevated observation post 300 feet away, a naturalist spots a troop of baboons high up in a tree. So, we have a tree, and we have a naturalist. So we have somebody that is about 300 feet away from this tree. So we'll say that they're on a post over here, and that's 300 feet away. Okay, so let's see. Using the small transit attached to her telescope, she finds the angle of depression to the bottom of the tree is 14 degrees, while the angle of elevation to the top of the tree is 25 degrees. And then the angle of elevation to the troop of baboons is 21 degrees. All right, so basically what you have to know is that an angle of elevation or an angle of depression has to come off of a horizontal line. So if this is her, platform where she is, and it says that she finds the angle of depression to the bottom of the tree from there, then that means that the angle it has to come off of a horizontal line. So that means the angle of depression is going to come down this way. I'm just going to have a hard time drawing it. So that means that, again, it's coming off of the horizontal line. So the angle of depression is actually right here. So this is 14 degrees. Then you have to kind of remember what you know from geometry class, that when you have two parallel lines, which would be this one, and they're cut by a diagonal line or a transversal, you have alternate interior congruent angles. So if this is 14, that means that this angle is actually 14 degrees as well. So that's going to help you. You can see you've got this right triangle. You have this right triangle. Okay, so now we have two angles of elevation. We have the angle of elevation to the top of the tree. So let's just say this is the tree top. So that angle, again, coming off of this horizontal line is 25 degrees. So again, especially on this, I'm going to have a hard time drawing that straight, clearly. Okay, so that means that this angle right here from the horizontal up is that 25-degree angle. And then it says that, let's see, the angle of elevation to the baboons is 21 degrees. So let's say maybe the baboons, are right here. So now I want to draw that angle in. I might see if I'll change the color so it looks a little different. Will it let me do that? It should. Let's see. Maybe it won't. That's okay. Oh, over here. Let's go blue. Okay. All right, so let's see. So it's from here, again, coming off of this horizontal line and to where the baboons are. Oh, it's still red. That's okay. I'm sorry that I can't draw a straight line on this tablet thing. All right, so that means that this angle is 21 degrees. All right, so again, you can see these different right triangles emerge. So now you're asked different things really about your lengths in here. So what is the height of the observation post? That would be this one, right? So I'm just going to call it A since that's letter A. So you can set up, again, you know that this is 300. So this horizontal line, again, the distance between the post and this tree is also 300. So you can set up an opposite over adjacent. You can set up a tangent function to find A using that 14-degree angle. So then the other things you're asked to find is the height of the baboons. So that would be this height So you know the height of the post, again, is from here to here. So you can use this smaller triangle with a 21-degree angle to find, again, this height. Then the height of the baboons from the ground would be a plus x. Similarly, you can find this whole side using the 25-degree angle. So to find the height of the top of the tree, you would say a plus whatever you choose to call that. Okay, so I hope that helps. Like I said, it should.